All right, well, this recording is for cisp310. This is for the Wednesday class in fall 2018. And this recording is about the solution of question number 4 of the final exam. So at the upper right hand corner is the actual code to implement, and I know it looks kind of funny because we seem to be accessing things that are not really a part of the parameter, but for the most part, all we need to do is to implement the code as it is represented here, and then the rest, okay, it's not really that important. So for those of you who are curious of what this is actually doing, so I can spend a little bit of time to talk about that. So the actual implementation in C of this particular subroutine involves this part here, a comma and then a dot dot dot. That actually is valid C syntax. This allows for a variable number of parameters when we're calling subroutines. We typically don't use these in regular C subroutines because they can be a little bit tricky to use, and there are better techniques in these days, now that we have object-oriented programming and data structures and stuff like that. But as a simple mechanism, this is a very convenient and efficient way to allow a variable number of parameters when we're calling a subroutine. So that's kind of the context of this particular exercise. All right, but even without understanding that part at all, all we need to do is to implement the program using the usual way, and let's go ahead and do that now. So I'm going to scroll off the text here so I can get the entire screen to write the actual solution. So we start with, I'm taking off my watch right now because otherwise it will scratch the screen. Okay. Okay, so we start with the label of the subroutine, which is sum, and it has several things on the stack. So I think it is best to use the label approach. So to use the label approach, the last local variable s is going to have an offset of 0 from where the stack pointer points to, because that's where the stack pointers, that's after we allocate for all the local variables, that's where where the stack pointer is going to be pointing at. The next one up is p, which is s1 plus. It is 1 byte on top of s, local variable s. And then we have the return address. The return address is p1 plus, and then we have the only parameter, which is x. So x is return address 1 plus. So now that we have all the items with names, I think it really helps to make it easy to access items on the stack. So now we are ready to implement line 5. To implement line 5, the first thing we need is the address of x. So we do a LDI AX, and then we add AD. That is now A has now the address of parameter x. So we now use another register to specify the address of p. So LDI BP add BD. So now B has the address of P, and then A has the address of X. And we need a ST instruction to store to local variable P the address of X, which is stored in A, register A. So that gets line 5 done. This is for line 5. Next, we need to implement line 6. Line 6 is a little bit easier. LDI A0, that's our right hand side, and then the left hand side is S. So we have LDI B S and then we have add BD, and then the store instruction to where B points to, because B has the address of local variable S, and A has the value that we want to store, which is just 0 in this case. So that's line 6. And then we have the loop after that. The loop is just saying, when, as long as P is pointing to a byte that is not 0, keep doing the following. So as with any type of loop, we have a while begin, or however you want to call this label. And then we have a condition to branch out to exit the loop. So we have to do a LDI AP add AD and then LD AA. At this point, register A has the value of parameter P, but that is not actually what we need, because we need what it points to. So we need another dereference. So we have ADAA again. So now A has the value of the byte pointed to by P as a local variable. And now we can do an AND AA, so that it would set the Z flag if A is indeed 0. And then we do a JZI to while end. That's our exit condition. And then assuming we're going to fill in the body here with the body of the loop, the last thing we need to do in the loop is an unconditional branch JMPI back to while begin, and then the end of the while is here, while end. And then we have one thing to do right before we do the return. We have to specify a return value based on local variable S. So we do a LDI AS add AD and then a LDAA. So now register A has the value of local variable S. The return value is now specified. And then you have to increment the stack pointer twice, because we have 2 bytes on the stack for our local variables. They are now useless. And then we have an LD BD, an increment D, and finally a JMP B to get out of the loop, to get out of the subroutine. So technically this is line 13. This is the end of the subroutine, whereas this part here, this part, not counting that part, is line 12. And line 7, it's kind of this part here. Alright, so now we have to implement what is inside the loop. So we'll start with line 9 here. So with line 9, the first thing we need is whatever P points to, and we already have that in register A. So if you want to reuse that register, we can, and then we just need to calculate what is in S. So we have LDI, don't use register A because we want to keep that around, B with S, add BD. So this will give us the address of S, and I want to keep that around. I want to keep the address around because after I load and add, I have to store back into that location. So the next one is an LD instruction. I'm going to use the third register available. So now C actually has the value of S. Then we want to add the value of A, which is the value of what P is pointing to C, which currently is the value of S. And then we store that back to whatever B points to, because B at this point has the address of S. So we store indirect into B, register C. That gets line 9 implemented. So this is line 9. And then the next one is just to increment P. I have lost the address of P already, so we have to recalculate it, which is not too bad. LDI AP add AD. So now register A has the address of local variable P, and we just want to add 1 to it. So first of all, we have to load the value of P into B, add 1 to that, and then store it back, because that's what the loop wants to do, is to increment the value of P. So we store register B back to where register A is pointing to. This is line 10. So collectively, these two lines go in here, and that's the implementation. So with this particular question, what I'll be looking for are the concepts of taking the address of. Okay, so let me start with the most important part. Taking the address of X is just this part here. Okay, so that's important. I also want to know whether you can store something into a register, into a local variable, and that has a few places. So so for that part, this is one chunk of code. This is another chunk of code to illustrate that you know how to do that. And then I also want to make sure that you know how to dereference a pointer. So the dereferencing of a pointer is right here, particularly the second dereference. That is what we need in order to get the value of what P is pointing to. The rest, we kind of have most of those already. Adding whatever P points to S is done here. So there's a little bit of this that I want to see as well. And then there's also the structure of the loop. So the structure of the loop, it kind of overlaps with dereferencing, because you need to do the dereference before you can implement the loop, which is the yellow part, and also including this part here. So that's kind of the control structure of the loop. And then I also want to know that you remember to deallocate the local variables. So that's the last two increment D instructions. And also deallocate the local variables, which I forgot to do. Woohoo! Okay, so I forgot to do that part. So we're gonna insert here, and we have two decrement D to allocate the space for our two local variables. So that's semi-important. Yeah, so I think that's going to be most of the things that I look for. The other one, would be the sequencing of how things are arranged on the stack, which in this particular program is indicated by the label definitions. If you do not use label definitions, then I will have to track down how you use register D and other registers to compute the address of various items on the stack. But essentially, that's what I'll be looking for when I grade this particular question. And this marks the end of this particular video.